Okay, so we're moving on to the skin shading part of the process now. So the first thing I'm going to do is select the model and apply subdivisions to it like we did with the eyes, with the IGO. So very simply, just selecting the model and over in the attribute editor down to Arnold and then subdivision. And the iterations is totally up to you. I'm going to stick with 2 for now. My model, as mentioned earlier, is at a relatively high level anyway, so 2 should be sufficient. So you can see there that the model is now subdivided. We're not getting any more faceting. So what I want to do now is just apply my ZBrush displacement. So my bait displacement from level 3 to 5, which just contains some of the sculpted details that I worked on. And I just want to get that in there. So before that, let's apply the shader as we did before. So applying the standard surface and then just renaming it. Then jumping over into the displacement and then just touching my file. Alright, and then setting the file to utility raw. And so when I press play, I mean, it's probably not going to make much difference, but there may be some signs of a bit more detail in the subdivision 3, which I exported out as, has a lot of detail already baked into the model itself. So this is really just a way to enhance that information. Get a bit more sculpted details in there. Just playing around with the shader so I can see the displacement a bit better. So we'll be applying a range node onto this later, so we can actually increase the intensity of the map. Okay, so now what I want to do is jump into the Hypershade and actually set up the texture XYZ projected displacement. There is a script on the website that you could just download and import straight into Maya, and you can just add your maps in and it's all done for you. I'm just going to show you how to do it manually, just to kind of explain the idea of the 3-channel process and how we can control those. It's not necessary to do this manually. I just thought I would explain it. Obviously, I didn't design this script. I just thought it'd be interesting to see how this is working. So essentially, I've just separated my original ZBrush displacement and I'm added another file node now and just adding in my XYZ displacement and setting that to utility raw also. Okay, so the first process is just creating a layered texture. And if you just click on the space there, you can create a second input. If you connect the out color to the color there in the input 1, set your blend mode to subtract, and then replace the green color with a mid-gray color, so 0.5. In my case, I found around 0.45 worked pretty well. I then create 3 blend color nodes. So each of these represent the RGB channel of the map. So the red channel, which is primary, green channel, which is tertiary, and then the blue channel, which is micro. So I'm just naming these here. And then simply red goes into RGB of the blend color node. So green goes into the RGB and then blue into the RGB also. So you should see these sort of orange arrows attached on each blend color node. Just change the color to black, and I'm just changing the blender to 0 for now. So we can actually start from nothing and then increase it. I then create a plus minus average node. So this is going to allow these maps to be added together. So I bring over my ZBrush displacement, I connect that to the first input, then the R, and then the green, and then the blue. So essentially what I'm saying is I'm adding all of these maps together now. I then can take the red channel of this plus minus average node and then bring it over into the displacement, and that's it. So now what we have is channel of this XYZ map plus our displacement, and then we can test and see what this looks like. So I'm just creating a region here and press play just so we can get a snapshot with no XYZ displacement, and then we can start to slide up the blender amount. Okay, so I'm going to start with the red channel and I'm going to put it on 0.1 and snapshot and press play. Okay, and immediately we can see some detail there. So from a smooth model to actual skin pore displacement now. This is the red channel, so this is the larger shapes of the skin, and then green is more fine, and then obviously blue is the micro, so it's very fine displacement detail. So you kind of go down in intensity. So I sort of set my green to about around 0.075 and then the blue to around 0.01. But this is totally dependent on your map and the intensity of the displacement that you want. And it's something that you're definitely going to play around with when you start applying specularity and subsurface. Okay, so what I'm going to do now is add my AI range node in between the displacement and the plus minus average. So just adding the AI range and the out color into the input, and then the out color of the range into the input 3D of the plus minus average. And I'm going to just type in a multiply 3 just for demonstration's sake. And when I hit render, you'll be able to see some more pronounced wrinkles. So very subtle stuff, but just having that control there allows you to kind of push your ZBrush displacement separately from your XYZ and having that bit of extra control there really. And this is what the render looks like overall right now with our displacement. So I think now we're ready to jump in and add our diffuse map and start seeing some color on there. Okay, so I'm going to right click and graph the shader. Hit tab and connect the file texture to the base and subsurface color. Once I've connected my diffuse, I'm just going to set it to ACCG. Just selecting a region, pressing play on the render. So ACCG will naturally make your textures seem very red and saturated. So we can connect the color correct node and actually fine tune the values and get a better color response. And the great thing about color correct nodes and doing all of this stuff inside of Arnold means that as we play the renderer, we can slide the values of the color correct node up and down and see in real time the actual look of the map, and not worry about jumping back and forth into different softwares and hoping that we get the right color or value. So this is a great way just to do things a lot more efficiently. Again, always looking at my references on the side as well. It's difficult to know without any specularity what the color of the skin should feel like, but yeah, it's just a matter of studying a reference. Okay, so now I'm gonna bring my subsurface weight up to 1 and press play. And you can see obviously that the scale is wrong, so we're getting this kind of a balloon feel. So I'm going to change my type to random walk version 2, which is the latest model from Arnold, and then change my scale to 1/10 of the original default. So 0.1, and we now have some subsurface that feels relatively good on the skin. Okay, so the radius is a color that defines the color of the bleed, which was discussed earlier with the eyes. Essentially, we want this to be a kind of peachy color. So I'm just testing it with a full red just to kind of show you what this does. And it gives a lot of artifacting, especially a lot of green artifacting, which I don't find is very pleasant. So, like I mentioned in a previous chapter, I wouldn't recommend having a solid saturated red color like this. You want something more in the peachy tones, maybe pushing it into the yellow slightly. You still get a sort of a red bleed, but it's not going to give you lots of artifacting. It's going to feel a lot more natural and subtle. So just making sure to bring my value down into that default ASUS white value that I mentioned before as well, so we don't get anything that kind of breaks any physicality, starts to cause artifacting. So this is why you're still getting a very translucent balloon feel with this color, because the value was too high. So now that I've dropped it to just below 0.82, we're starting to actually see the displacement coming through now, and the bleed is just a lot more natural. But of course, it's still a place where you can continue to fine tune. So subsurface scattering is very important. Obviously, a lot of people do overplay it, and they tend to get a lot of glow appearing on the skin. The idea is that it's subtle. You kind of want the subsurface to feel like it's an afterthought rather than the first thing that you think about, because when you look at anyone's skin, you're not looking at someone's subsurface scattering. It's just a natural part of how the skin reacts to light and how light penetrates the skin. So it's about subtlety, I think. It's not about having super red nostrils and glowing skin. So I'm just playing around with the anisotropy now, and I tend to just put this value, which I've only just started doing recently, on just over 0, so maybe 0.1. It just adds a little bit more forward scattering, allows a little bit more of that translucency. So this is testing it on 0.3, which I found was too much, so about 0.1 should do the trick. So it's giving it just a bit more of that red fringing around the shadow. Okay, so I'm gonna do another region. You can see the difference between the no subsurface and the subsurface that we currently have as well, and how much the displacement gets washed out, which is why I say about how you'll continually fine-tune your values for displacement as you render. Just decided to push the radius up into the yellow slightly more. And there are some glowing eyelids there. You know, this is something that potentially will need to be masked out using a subsurface weight map. Not completely turning that off, but essentially painting a map that just lowers the amount of subsurface that happens along the eyelid, so you can remove that excessive glow. And constantly monitoring my progress, snapshotting each attempt and comparing them, seeing if I prefer previous or the new attempt. So yeah, look dev is a lot of patience and a lot of fine tuning. You can see here that I've lowered the scale by half. I reduced a lot of the glowing on the eyelid, getting more displacement back. Less of a balloon feel, I feel, to the nose. Potentially could use a touch more subsurface. Starting to feel a little bit diffuse. Cool, so there's a before and after. That was the original diffuse, and then with the subsurface. Alright, so jumping back into the Hypershade now, I'm going to start connecting the other components of the shader. So here I'm grabbing the specular map, connecting the R channel, connecting the out color to a color correct node, and then the R channel to the specular attribute. Then I'm just going to do the same thing for the roughness. Just setting both of these maps to raw. So an important thing to note here is how much the roughness changes the kind of value and look of the skin. So, you know, the shinier the skin is, you kind of get a darker kind of feel to the skin with, of course, brighter highlights. So I'm actually jumping into my render settings now just to kind of ensure I have enough samples to kind of start seeing the skin in better resolution. So just kind of increasing some of the ray depth values and the specular samples there as well. Of course, this is going to slow down render time, so just be realistic with the values that you change. No need to do anything too drastic. Just turning off depth of field on one of my cameras, so I can actually see the detail. The nose will be slightly blurred in most of my renders, so just want to get rid of it for look deving. In the render settings, if you jump to the AOVs, you can actually add a specular AOV. So I just add the specular direct AOV, just selecting it as well as the coat, and then I just press the forward arrows, and then that way when I press play in my render, I can have a beauty and a specular direct AOV there. This is a great way just to see what the specular is doing on its own without any color information. So right now I've just selected and I've isolated my specularity map. I've selected the color correct mode rather than the map itself. This way, as I fine tune the map, I can see the changes. So I've just increased the exposure of my map to 1, so you can see a lot more specularity now coming through. If you find that you're getting a very flat color fill to your model, it's probably because you need to increase the amount of specularity that's happening, obviously. So if that's a map, it means increasing the exposure or potentially bumping up the IOR slightly. You know, IOR off skin doesn't have to be 1.4, which Arnold suggests. It can be, you know, just above 1.5. There has been research done on the index of refraction of skin, and it's not exactly 1.4 for everyone. So feel free to sort of play around with that value as well. So now doing the same for the roughness, just sort of playing around with some of the attributes here in the color correct, seeing if I can create something a little bit more contrasted. And you can see the darker the blacks, the more of these shiny highlights you're going to get. It's going to give you a slightly plasticky feel, but it's just a good way to experiment and see exactly what the map's doing and how it's driving the look of the skin. So you can see having some of that extra added detail in that roughness map just helps create more variation, more breakup. You know, the important thing to note, and I've mentioned this before, is that textures are a huge part of how your look dev is going to read. So the more variation you can add into your textures, sort of the more randomness you can add, the more interesting I feel like the renders will be, because that you're not just using flat colors and flat values, but instead there's a range of variation, you know, ranges of blacks and whites, which is going to create just pings in certain places of highlights and other areas which are going to feel a bit more flat. And this is sort of how skin reads. There is a lot of variation going on and a lot of visual interest, and being able to capture that is a huge part in the textures. So yeah, it is about spending your time in those different departments. So when you come to look dev, you have enough to play around with and enough to try and achieve the best photorealism that you can. So you can see already here when I'm comparing the before and after just how much the specularity is allowing the skin to actually read now, and it's bringing him to life slowly. Okay, so comparing before and after, you can really see the brighter highlights, the specularity on the cheeks. Skin doesn't feel very flat color anymore, but you're actually starting to read that variation of specularity over the top of the color. So yeah, starting to get some decent results. Okay, so I'm going to introduce you guys to something which is going to be talked about quite a bit in the next chapter, but it's using something called an AI layer RGBA. So I'm going to show you how to use this for the subsurface radius, just as a sort of an introduction. So I've just created a node and I've connected the out color into the subsurface radius, and I've set layer 1 to just that flat color that I chose for the radius. Then what I'm going to do now is select the color correct node, and in that I'm going to connect a file. And this is a map that I created when I made this project, which I used for the subsurface radius, but I've decided now that I think it's just a good complementary map for it rather than it representing the entire map. Okay, so I'm going to select this RGBA layer, and I'll show you what this map looks like. Essentially, it's taken from the diffuse with some sort of hand-painted color on top, and then some veins that I painted, kind of representing a subdermal layer of the skin. Was kind of the idea of what I was trying to go for. So the map looks like this, and you can see it is very red. It's not really the sort of color I would use now. I'd like to use something with a little bit more yellows in there. So I thought what I'd do is I'd layer it, and I could say that I can overwrite with this map, but on a certain mix, which is like opacity. So I can say, right, I want it on 50%, so the rest will be read by that layer 1, which is that flat color that I chose. So this way we're still allowing some variation, but I have a little bit more control here. Even if I want it maybe on 10%, I can drive that mix to 0.1. So it overwrites the input 1 or the layer 1 with the percentage of the mix. And you have lots of different layer types like that you do in Photoshop, things like multiply, screen, soft light, things like that. So it's very useful. You can see here I'm just trying to get the map to kind of blend with that original radius color, so that way we have a similar color, but it's got lots of that detail and color variation in there. So you can see that the flat color, and then the new radius now with that map introduced. Just adding some interest, adding some variation. That's something that you can continue to tweak. And you can see the different operations that you can add here as well, and the effect that they can have. Okay, so turn off isolate selected, and then we can take a look at what this new render feels like. Yeah, I don't usually add a subsurface radius map in my work actually. Usually I do use just a flat color, but I thought it'd be an interesting way to kind of show you guys that you can introduce a different range of maps to your work, and how you can use certain nodes to kind of introduce these maps, but maybe have them on a very low intensity, and be able to play around with that in order to just introduce that variation like I mentioned, and be able to kind of always have some sense of randomness and potentially subdermal veins and things that can may not be instantly visible, but may make some sort of difference when you actually look at the piece. Alright, so now what I'm going to do is add a color correct like usual, and then connect another file, which is going to be a map that I painted for the coat. Essentially this is like a specularity map, but instead it's a little bit more focused on areas that you just want an extra layer, potentially like oil and sebum to the skin. So again, setting it to raw, adding my coat map, and making sure that it's the out color R into the coat weight rather than the out alpha, which won't work. Okay, and you can already see it at work here. You can already see the intensity of the coat there. So it's just a way of adding some of those really sharp highlights to the skin in certain zones that you feel are more oily. So that would be kind of your T-zone, so your nose, forehead, potentially around the cheeks and around the eyes. So just changing the bucket size here so we can actually get smaller render increments. So again, like anything with LookDev, this is just about playing around. You can use your AOV passes there to kind of isolate that coat or the specularity and see if you're getting the feel you like. Remember that these two are going to be added together. The coat is going to sit on top of the specularity. So it is a fine tuning thing. You don't want the skin to all of a sudden become very, very shiny and plastic looking. So it's a fine tuning thing. So using that color correct node to potentially lower down the exposure of the map. And then using the IOR to decide how reflective it's going to be. So I kind of changed it to something a bit more like water because the specularity is already doing quite a bit, and I just wanted it to be a very subtle, slight extra ping to those areas of the skin. Alright, so what I'm going to do is continue to fine tune this coat here, and in the next chapter I'm going to be going on to something a bit more advanced in terms of using this AI layer RGBA, which I mentioned earlier, in order to start building sort of a mask system that we can then use to kind of actually drive different regions of the face in terms of specularity, roughness, even color. And this way, everything can kind of be built and edited inside of the renderer without having to jump back into texturing. And this is obviously up to a certain point where you feel like your textures are good enough. For example, the stage I'm in here, I know my textures work, but I just want to fine tune those textures and make sure that I'm getting absolutely the best results I can, and I'm not limited or restricted by the textures that I have. Right, so we're moving on to more advanced skin shading now. So I'd introduce this light stage from Cave Academy. So on the timeline, you have animation keys built in, which will allow you to kind of change the light. So you can see there with the red lights there, that's showing you the lights that are being activated as you flip through the frames. So it's a really great resource, and it's, you know, exposed my model in a different way now that can allow me to kind of decide to make some changes. And the first thing I feel here is that the iris feels quite small, so I thought I would just go to my sclera shader and just slightly tweak the ramp just to kind of give his a bit more diameter to the iris there. So very subtle tweaks, but it's a great way just to expose your model in a different way and not get too comfortable with your light setup. I also feel like his skin feels quite red. You know, the lights that I set up for my sort of interview kind of setup here, you can see has quite a bit of a blue tint, which will neutralize that red. So seeing it here with this kind of with these lights which are just on white, it allows me to see that maybe I need to push a bit more oranges and yellows into his skin, maybe a little bit less saturation too. So yeah, this is what I meant at the start when I said about, you know, using lighting that you're uncomfortable with, because it's just the best way to kind of push your shaders, push your materials, and not get too comfortable with a single setup that you've made to kind of flatter your model. Because, you know, in the industry, you may have to, your model may have to go into some difficult lighting, whether it's maybe outdoor exterior lighting or under some sort of some lighting that maybe just doesn't flatter the model as much. So it's a great way to learn how to force yourself to change things and tweak things based on different light environments. Look Dev, the art of it is all about kind of understanding how materials will work in the real world. So it should work with any environment that you decide to put your model in. And that's the idea here. So if I tweak the shader, you know, tweaking the subsurface scattering, you know, seeing how things feel, I'm already getting a nicer feel now just from these small tweaks. And I'm taking a look at the different AOV passes and looking at the coat response and the specular response and seeing how they sort of play together. So yeah, turning on to this really contrasted lighting here now, I've noticed just how the coat response isn't really acting the way I want it to. It seems to be very large hits of the spec that's happening through the coat. So I'm just going to graph my skin here and just make some changes to the displacement, maybe a bit more micro intensity will allow a bit more breakup on that coat. She has done slightly, but I'm still kind of getting a very bobbly feeling to the skin, which I don't think looks very nice. So need to potentially do some work to the coat. So here I've just changed the IOR to 1.4. I'm just making tweaks to this subsurface radius. Decided to have a little bit more orange into it, a little bit more yellow. So now I'm just pushing the frames around so I can actually get a backlight now on the back of the ears. And this was quite a noticeable change that I had to make. So I noticed that really when the light hits the back of the ears, you should get a lot more subsurface scattering. That kind of feeds through the entire ear rather than just kind of the outer perimeter of the ear. So I thought this is probably quite telling in terms of my subsurface. So I thought I'd experiment, see what it looked like when I was tweaking the values. So obviously 0.675 is way too high, but this is the kind of response that I want when the light hits the back of the ears. So I put it on 0.15. I decided to push up the scale slightly. I think I'm getting a better response now. Feel a little bit more of that scatter through the entire ear. So I'm having more problems with the coat response. I feel like the specular response feels good. I think the coat is feeling a little bit like too glossy. So just constantly changing the lights. I'm checking my AOV passes for the spec in the coat and just making sure that I feel the coat is actually complementing the specular rather than feeling like just a totally different layer of gloss on top. I want it to feel, like some sharp pings of light, but not something that looks sweaty. And of course, there's loads of ways that you can approach coat. So you can definitely take the roughness and put a noise map in there, so you can have lots of variation. So the darker it'd be very shiny, and then you could create pings that way as well. So there's lots of different ways that you can experiment with using coat and using different noise maps and variation maps that can add different subtleties to your materials. So obviously the further away I get, I'm going to get a bit less resolution on the skin. It's not going to be very helpful to me, so I just thought I'd go to something much closer up, like this angle here. Take a look at the skin. Still quite on a low resolution image, so at some point soon I'm going to definitely increase it. So I'm just testing to see if my specular IOR could increase slightly. Like I said, don't feel like you have to leave it on 1.4 because it's the skin preset. Skin can range to over 1.5 in IOR, so depending on the person's skin. So yeah, it's sort of about experimentation really. Don't feel restricted by values that are presetted for you here, but also do your research. There is research online about the index of refraction of skin, how skin responds to light. So these are things that you can study and learn and try and implement them into your shader. So the coat is supposed to act as almost like an oil layer that sits on top of the skin, your sebum, but just kind of in those areas where it's mostly oily. So forehead is one of those places. So I'm just testing that here, and I'm getting a nice sort of subsurface response here, which is feeling better. The coat isn't feeling too invasive, so I thought I could maybe lower the roughness to get a little bit more of that ping. Just isolated the coat map, seeing if I can play around with it slightly. Let's just refresh my render. So I thought I'd do a test, remove the coat completely, see how that feels when I remove the coat and when I have coat on top, and I feel like it's actually complementing the spec now. It's just adding a little something, but not too much. Of course, here I've got lots of depth of field, so just going to remove that. So my first initial thought here is I need to remove or reduce, the amount of subsurface happening on those eyelids, because they seem to be glowing quite prominently in every light angle, which is telling me that it's too much. So this is where we go on to using layers, and this is the bit where it becomes a little bit more advanced, and you're allowing yourself more flexibility in your shader work. So just creating an AI layer RGBA, and I always call the first layer base, and the base is white in this case, which means full subsurface weight. And you can see there, nothing's changed. And I've connected the R channel of that RGBA layer into the subsurface weight. So layer 2 is going to be a mask. So if I jump into mix and I create a file, and in this file will be one of my masks. In this case, it will be the eyelids. So these are just black and white masks that I paint in something like ZBrush or Mari or Mudbox, whichever you choose. As long as they have a nice bit of feathering around them and some blur, then it's all good. Nothing too sharp. Because these are TIFFs, I just jump into RGB texture. And the mask needs to, like everything else, needs to be connected by its R channel into the mix. So just doing that there. So these are obviously black masks on a white background, which means if I multiply, I can see what happens here. So I've just disabled it. And when I enable it, you can see the mask there at work. But the mask is the inverse of what I actually want. So I can just jump into the file node, go under effects and invert. And then I now have the option to change the input color. So from black, which means I'll remove subsurface scattering in that area, all the way up to white. So I have lots of flexibility here to kind of grade that region of the face. And if I do a before and after, I have to do a refresh. And yeah, so you can see here, I can turn it on and off. So lots and lots of flexibility here to kind of reduce subsurface scattering in these regions. So that's how you can use masks to drive things like subsurface weight. So you can just go into layer 3, 4, 5, 6, etc. and just add in your masks. And now what I'll show is the diffuse. So if we create another RGBA and I connect my color corrector, my diffuse into the input one, and I'm just quickly renaming all of my nodes just to kind of clean up my scene, because it's going to start getting a little bit more cluttered, be easier to navigate and find stuff. Cool, so I'm just adding a file node and then connect it to a color correct and then into the input 2. And I'm going to start off with showing how you can use cavity maps to drive some sort of wrinkle detail into your diffuse to kind of align with your sculpted detail. So this is a cavity map baked from ZBrush, so it corresponds with the sculpt. And essentially this goes into the input 2. And I'm going to just isolate selected so we can actually see the, so this is the cavity map. And if I enable layer 2, so enable the cavity, And instead I've chosen to put the channel R of it into the mix. So that way I can change the actual color of the input. And if I change the operation, you can see the map there. Just invert it in the color correct node. And I'm just experimenting with the operations here. So I think I set it on multiply, which gives me the dark color in the actual wrinkles, which is what I want, and that slight lightening on the outsides of them. And you can see I can slide the color correct multiply up and down to kind of completely remove it and introduce it. And I can use the input color to actually change the color of it. So there's lots of flexibility here again. Lots of ways to add a bit more variation and interest into your diffuse. Because these sort of color details do actually exist in people's skin. You know, I've worked a lot with scan data, and where you have wrinkles, you usually have color information too. It's not just displacement information. There is color aligned to it. So it's important to introduce some of these things. So what I've just done is I've just screenshotted the diffuse without the cavity on top, and then now I'm just trying to grade the cavity part in order to kind of match with my skin tone, so I don't constantly keep changing the skin tone when I overlay stuff onto the skin. So this is just a kind of an exercise in color correcting, and it doesn't matter if it changes slightly, but as long as it's not gone completely saturated red or totally changed color, then all is good. So I'm just adding a new layer now called potato. So this layer is essentially just a tileable map that I found online a long time ago, probably just from Google, and it just looks like this. It's just a tileable map. Again, just changing that to sRGB texture because it's a JPEG image. And if I enable it and set it to soft light, press play, you can see the map there on top. This is going to be adding some of those red blotches sort of variation. It's actually the skin of a potato, but it has lots of variation. It kind of resembles skin. So it looks a little bit like this when I tile it. And again, the exercise here is to have it, you know, subtle and also color correct it in order to kind of match the original color of the skin. Because the thing I don't want to do is change the skin tone too much. And then, you know, these layers are meant to complement the skin and add more detail, but not change the actual color, but more just the look. So that's without and with. See, just on a layer of maybe, so something like this works, you know, it does change the color overall, but it's not something drastic. It's just adding all of those sort of freckles and spots and blotches onto the skin, which is kind of what I want. So just continue playing around with it some more. So I feel like the skin's saturated slightly too much, so I've just tried to kind of neutralize that whilst also keeping the potato skin layer on top. So I think I found a good balance now. And I think potentially the the potato layer has brightened the skin, which at the time I didn't really take much notice of, but sort of towards the end, I think the skin definitely feels too bright. So, you know, again, that's why I mean by trying to neutralize it, making sure that you're not going brighter or darker or more saturated or less saturated with these layers. So yeah, it's just an exercise of color correcting, really. So now I'm going to introduce a layer into the displacement setup here. So doing the exact same thing, I'm going to create a layer RGBA and connect a file to the mix. And this one's going to be a forehead mask. I'm just going to invert it. and I'm going to set it to multiply. And the idea here is that I want to multiply our masks by the XYZ layering. So what I'm going to do is create another plus minus average node. The ZBrush and the original plus minus average can connect into the new one, and now we have a separate plus minus average for the XYZ layers. So I'm just connecting that into the layer RGBA, into the input one, and then the forehead mask can go into input 2, just like before, setting it to multiply. Takes a bit of time to understand how to kind of set these things up. Sometimes I still get a little bit confused, so I just experiment with it. So just enabling the forehead now, and with it set to multiply, then now what you can see is we have no XYZ displacement, but we still maintain our ZBrush displacement there. So this is working. And again, using the input color, so black meaning completely masked out, completely black, which means no displacement, and white meaning the full value. So you can see here already how we're able to drive different regions of the face and reduce the displacement based on the look that we want. So you don't feel restricted again by the maps. You know, again, spending time on the maps is very important, but feeling unrestricted by them when you're doing look dev is very important, because you're never going to be able to paint or create the perfect map. So this is a way to be able to dial things up and down and tweak them based on your references, without having to do too much back and forth towards the end when you've created some good maps. Even, for example, the diffuse, which was hand painted, I didn't obsess in Mari over getting every tiny detail, because I thought I could probably just drive a lot of this detail inside of Arnold itself and actually be able to see that while I'm rendering and see if it works or not. So it's a really efficient way of working. And I'm just going to set up the cheeks into this setup here. So connecting the R channel into that orange input there, and then just setting it to mix 3, calling it cheeks, setting it to multiply, and then making sure you're always connecting the R channel, and then just quick save and pressing play. And remembering to invert if your masks are black on white, because essentially a black map on white means that the white area is the bit that's being affected. So I need to invert it to kind of say, right, I want the cheeks to be affected, not the rest of the face, except the cheeks, if that makes any sense. So really, you'd paint a white mask on black, so the cheeks would be painted white to affect the cheeks. But I just did it the other way around, so it doesn't matter. You can just invert it. It's as simple as that, really. So I thought what I'd do is introduce that HDRI map from the very first chapter and take a look at what that looks like. See if I'm getting any cool skin response. I'm getting some really nice sort of pingy highlights, which is nice. So that's working quite nicely. So yeah, I definitely think I could benefit from lots and lots more layering work. So things like using a lip mask to kind of maybe darken the lips slightly. They feel a little bit too bright. And just, you know, using the mask to weight things and alter the color and displacement look. So yeah, so I've just now jumped into my render settings and I've just updated it now to 720, HD 720. So I'm going to get a bit more resolution. And yeah, I feel like it was about time that I actually up the resolution now. Potentially updating the render settings. Obviously, again, making sure not to be too slow. Just so I can see the skin in a better light now. We're at a good stage where I really want to start diving into the smaller details and really play around with the light environments and make sure that I'm really pushing the shader as much as I can. So I'm really seeing here that the subsurface on those eyelids still feels very glowy. So I thought what I'd do is jump into the subsurface weight and enable a layer 3. And I'm going to call this under eyes, which I've got a mask for. So the eyelids would be that sort of rim of skin around the eyeball, and then the under eye obviously is the eye bags. So just bringing that map in. Just regraphing my network here, and then just finding where I am. Eye bags, connecting the out color R into the orange input, setting it to mix 3, and then inverting my map. So I'm just seeing it without, and then I'm going to turn it on and see it with. Setting it to multiply. And you can see there where you've got no subsurface under the eyes, so it's completely diffuse. And then being able to slide that up and down again is all about the results that you want to get. But I'm able to reduce, you know, the subsurface effect in different regions, which is really important, because you're never going to get a perfect model from base values. And sometimes you are just going to need to drive things using these masks, or painting the maps and, you know, tweaking them based on the look. So right now I'm just jumping back into my original light setup. Sort of after all of that sort of look dev exercise with the light stage and the HDRI, you know, and obviously spend a lot more time doing that, doing all of the layering and masks, and then constantly changing a light environment, you know, using the light stage to kind of spin the light around the model. Once you get to a good stage, you can then jump back into your light setup, or something a bit more flattering, and then see if it still holds up, you know, continue to make some more changes, and then it's, you know, you come back and forth that process all over again and iterate. So lastly, I'm just going to show you using the layering system for roughness. So again, using our RGB layer node. So layer 1 is going to be our base again. So it'll be our actual roughness map. And then I've decided to alter the roughness of the lips here. So just file, navigate to my mask of the lips, RGB texture, and then setting the R channel into the mix, inverting the map, and then setting that operation to multiply. Again, I have that slider there, so I can, as you can see when I'm flicking back and forth, I have all of that flexibility to change the look of the lips here. So now I'm getting a nice bit of specular hit on the lips, which feels good. So again, just altering different values. So yeah, what this means here is that on an input of black, the lips will be darker, will be black, so it will be really shiny, and then obviously as you bring it up to white, you're going to get a rougher feeling on the lips. So using that slider to adjust the roughness in different regions of the face. So again, you know, it's just an incredible flexibility to be able to have in look dev, and you can paint masks for absolutely everything that you want, and just create a really nice setup where you could just drive everything inside of Arnold and not have to worry about going back into texturing too much unless you absolutely need to, you know. Yeah, I mean, hopefully this introduces you guys to, you know, using layering, using masking system to kind of really push your shaders, and just learning to be uncomfortable with different light setups, learning to look at your model in unflattering ways. So obviously this is something that I would spend weeks on, and it's only been consolidated into a very short time for this tutorial. So it's just a kind of introduction into the techniques, but go away and really push your shaders and push your look dev as much as you can. It's very important to spend that time. You know, this isn't something that you're going to get done in a day. It might take you a month, it might take you a few weeks, it might take you 3 months, but it's all about learning. So I think this is a good place to kind of end chapter 4. Okay, so for the final chapter, we're going to be looking at hair and clothes shading, and I'm just going to introduce you guys to the hair stuff first, just to kind of show you, since the last chapter I spent a bit more time tweaking the shaders. Think I brighten the skin too much, so I've brought the value down of the skin, tweak the you know, the layering system, a lot more layers in there now for, you know, the subsurface weight, displacement, roughness, things like that. So now I have something that feels a little bit more crisp, and every sort of region of the face kind of feels a little bit more natural and sort of reflective of my references. So you can see there kind of how much brighter it was in the last chapter, and sort of having brighter skin obviously will increase the subsurface amount and make it look more glowy. So reducing the value of the skin is a way to kind of neutralize that amount of subsurface, but obviously only if it's necessary, and it definitely was in my scene. So okay, so I just wanted to introduce you guys to kind of painting textures for X-Gen masks. So obviously based on the geo that you grow your groom from, the UVs of that, you can paint masks on top of that. So I have painted an actual color map for the beard. So yeah, when you get into that sort of more advanced skin shading, it's definitely important to have up to render settings, be able to see the skin and the displacement response. And especially when it comes to hair now, we're going to really need those render settings in place to be able to really to read the hair properly. So the first thing I'm going to do is just click on my X-Gen beard node in the outliner and just right click in the viewport and assign a standard surface hair shader. And I'm just going to name it beard material. I'm just going to change the melanin amount to 0.105, so it's going to be very light, sort of white hairs, slightly blonde. You're going to really need to let this sort of stuff render, especially when it comes to whiter looking hair. It's very, very noisy. It's going to need more samples. So yeah, make sure that you're allowing the render to actually clear itself up so you can read it better, and don't judge it based on kind of that initial noisy bucket that starts rendering, because it can look like a totally different color and a totally different feel. So just changing some of the roughness values, you know, adding a little bit of that anisotropic roughness. There aren't really specific values for a beard, for example. You know, it's based on just references that I'm looking at. You know, I do feel that in some images there's a lot of glint in his beard, so I just thought I'd increase the IOR slightly more. The shift is based on some scientific research that was done, and I think for sort of Caucasian people it's around 2.8, but I can't remember entirely. But you know, I set this number after doing a bit of that research. So here is the actual where the map comes from. So I painted a beard map, and that gets created there, and it's called, you know, $ beard map, and it's a map that I just painted inside of Maya. So once I painted that, then I've just created a little setup here which allows me to multiply the beard color by a sort of a random amount, which is like a noise map, which allows me to have the beard color and then multiply on top some darker dots, which are going to be sort of randomized darker hairs. So I said they're 20% random. And then what I'll show now is how you can actually bring this into your shader. So if you hit tab and then type in user data color, connect it to a color correct node, and then the output color of that into the base color. So the name I'm using here is random, because that's kind of the beard color multiplied by the noise map. If I just wanted the beard color on its own, I could just input into the user data color beard color. But instead here, I want it to be the full thing, which is the beard color multiplied by the noise. So yeah, calling it random. And you can see here, this is the color map actually working here. So I've just selected the color correct node from the user data color and just isolated it. So you can see here the actual, all that color information. So I can actually tweak the color here, increase exposure, saturation, things like that. So yeah, this percent strand is allowing me to darken randomly 20% of the hairs to a color of 0.1, 0.1, 0.1. So that's what that's saying. So I'm just going to show you an example here. If I increase it to 62, and then we can see, if I do it before and after, that now 62% of the hairs are being randomized to be a dark color. So I'll randomly assign the dark color. So bringing it back to around 22, because I do want the hair to, you know, predominantly feel grey and lighter. But you know, there's so much flexibility here. You could very well apply a melanin map to certain regions as well. So that would say sort of where it's white is going to be dark hair, which means full melanin, and where it's black is no melanin, so it'll be white hairs. You could multiply different user data colors together, you know, or multiply different melanin masks together. There's lots of flexibility, just like with the skin. It's just knowing how to actually create this in the first place. And it's all created in the X-Gen preview output tab under custom shader parameters. and just being able to type in the name, select where it's color or float, color meaning color and float meaning black and white, so like a mask, and just pressing add. And very simply from there you can paint maps and then assign those using those user data color or user data float inside of the Hypershade. So yeah, that's how that was done for Jim. And you can see here the actual map that I painted. It's very difficult with that wireframe, but you can see the look of the colors and the complexity of the colors that were painted, just in areas that I felt were whiter or more brown or more black, depending on the reference. So again, realism is all about variation. You know, he is aged in my work, which means that, you know, I wanted to have all of that variation and get some of those grays in there. So that was kind of how I approached it. So now I'm going to move on to the eyebrows, and I'm just going to pick a camera that allows me to see his eyebrows. And I feel like groom stuff is kind of the fun part, because it's kind of when your character really comes to life, when they've actually got hair and eyebrows and eyelashes. So this is kind of the bit where you can really see your character actually come to life, and also allows you to kind of see, okay, maybe the skin needs more work now, because I actually can read this as an actual human with hair and eyelashes and peach fuzz and all these sort of things. And you can take a step back and say, all right, actually the skin needs more work in these areas, because your brain is going to start reading this more now as an actual human being, which almost allow you to identify further problems in your work. So it's, yeah, the hair stuff is definitely a big game changer when it comes to 3D portraiture. So yeah, like usual, I'm just playing around with values. You know, melanin, you know, on 0.05 is going to be like a brownish color. Playing with the redness amount. They're very simple parameters here in the hair shader for Arnold. It's not complicated. It's just a matter of playing around with values. It's not really much to it. You can, you know, use the base color as a multiplier as well. So if you want a little more redness or orange in the hair, then you can assign that there. All right, and then same thing, just bringing the eyelashes in, assigning an eyelash material. Very simply, just using a slightly red color for this. With a sort of a mid melanin, you know, the base color is going to multiply. It's going to be pretty dark now. So yeah, you can see the eyelashes now. And slowly, the human in him, his soul, is starting to appear with every groom update. And, you know, the eyes are now actually feeling more alive. So yeah, it's a good thing. Also, just that shadowing that happens on sort of the upper part of the eye from the upper eyelashes is a really key part in sort of realism and how we read faces and eyes. Like, you know, we're used to that shadowing, and it feels very uncanny when you have very white, unshadowed scleras. So just picking a smaller region so it renders faster and tweaking the shader slightly a little bit more. Don't want eyelashes that are too black or too dark. Okay, so rather than sort of going through each part and actually assigning the shader and showing you how I set it up, I thought what I'd do is show you a render that I'd done of the groom, and then just show you the attributes of each groom, because it's a lot quicker, and honestly it doesn't really get much more complicated than what I just showed. You know, you can assign ramps to the melanin very simply, like we done with, you know, the eyes, and it's essentially just sort of saying from root to tip the sort of the gradient and the color change that you might want to have. Yeah, and you saw the user data color that was applied to the beard, so that was also done similarly with the peach fuzz, just having a few darker hairs in place rather than them all being consistently sort of one uniform sort of white peach fuzz color. And then this is me just showing you how to kind of use a ramp on the eyelashes. You know, you can use it both in the base color and the melanin, just to kind of drive root to tip variation and say, you know, maybe you want the tips to be slightly lighter and the root to be slightly lighter. So the root kind of blends a bit more into the skin, and then the tips taper off a little bit more. So I noticed in some references of Jim Carrey that the tips of his eyelashes feel very blonde, sort of fade off into sort of a white color. So I thought I'd try and emulate that here, but nothing very complicated apart from the sort of user data color stuff I showed with the beard. Everything else is very much just ramps and basic values that I found worked well and were reflected in my references. So you can use, select the node, use isolate selected to be able to see what the ramp's doing. So with melanin, like mentioned earlier, when it's black, it means no melanin, so it's going to be white, and then vice versa. Just removing the depth of field in this camera again, just to kind of just to see the eyelashes. It's too blurred otherwise. It's a good angle to see how the light's hitting the eyelashes too. You can see even from my render here that there is a slightly small gap between the sclera and the eyelid, which is giving that really red glow. So these are things you can just tweak in ZBrush, tweak your model slightly, or even in Maya, push the vertices back slightly off the eyelid to sort of sit with the sclera. So, having these different angles and close-ups is like, a great way to expose your model and make sure that things are watertight and are sitting cleanly. So yeah, you can see I'm getting some lightening now on the ends of the eyelashes. So yeah, that's essentially what ramp does or allows you to do. Just getting that variation from root to tip. And yeah, nothing very complicated with hair shading for me. Hair shading can be very complicated, but with Arnold, it is very simplified, very simple parameters, and I feel like it does the job. I don't really spend too much time unless it's something where similar to the beard, where I've had to paint something to get lots of variation in color, which is a lot of fun and it does give some really nice results. But in terms of things like eyelashes and eyebrows, it's always quite simple, just some root to tip variation and nothing else. Okay, so we're going to move on to cloth shading now. I'm going to hide my geometry and extra stuff so we can just focus on the cloth and, speed up render times. I don't want to be computing skin when I'm not focusing on skin right now. So simply just going to hide this stuff, hiding the eyes, hiding the extra, and just trying to get a good angle for the tests. So my approach for cloth is honestly pretty simple. I don't really do much cloth work, and it's something I definitely want to get into more and actually recreate a lot more complex cloth shaders. But for this demonstration, it is relatively simple. It's very much just using a sort of a single tileable map and sort of using that to drive attributes like displacement, specularity, and just using references, of course, to actually emulate what is going on in real life with these materials. So it's going to be a leather jacket and just sort of your average sort of cotton t-shirt, and a metal zip and those sort of metal buttons on the jacket as well. So I'm just doing an initial Lambert render, and then we can then, select the jacket, right click, and assign the standard surface. Renaming it to jacket material. Opening up my Hypershade now and then graphing the jacket material. First thing I'm going to do is what we've been doing before, which is just a file node with a color correct node attached, and just plugging that into the base color. With cloth, you can experiment with subsurface scattering as well. I'm not going to demonstrate that here because it's something that's kind of down to kind of whether you feel like it's necessary on your cloth. I don't know if it's entirely necessary here, but it may help to kind of make your cloth work feel more natural. So yeah, experiment with it, and yeah, take what you're learning here and experiment with it further. This is a relatively simple demonstration of how I approach cloth with this project. So you can see I connected it to the subsurface there, but probably won't actually use it for the leather. Just in case if I do, then it's connected. Alright, so you can see here the albedo at work. I will just isolate this map so you can actually take a look at what it looks like. It's just a single tile, and it's just sort of sitting over the top of the entire jacket right now. So I'm going to take advantage of the UV coordinates option there and actually tile this. So go into repeat UVs, changing it from 1.1 to maybe 15.15. And we can press play and see how that feels. Great, so you can see it's tiled. The more you tile something, the more it can start feeling like a repeated texture, which is going to break the realism. It's going to start feeling CG. So you need to find a middle ground. And, you know, this is where you can potentially add noise and randomization to your albedo in order to break that potential uniformity that happens when you start repeating tileable patterns. So just going to do some color correcting. I want this to be a relatively dark sort of black leather jacket, not brown. So sort of adding a little bit of blue and then just desaturating the color. Cool, and then when I press the unisolate selected button, you'll be able to see the color and the initial shader at work here. And we can see it just feels like a very plain black shiny material. So never underestimate the power of just small variation, even if it's so subtle. Like here, you can't really see the pattern, but it's adding something, and it's a lot better than having a flat color. So always take advantage of tileable maps or noise maps in order to really add more variation to your work. So I've just added a plus minus average node, and I've connected that into the displacement attribute there. And I've got a file node, and I'm putting it to the input 1, and I'm going to connect another file node and put it to the input 2. So one of them is going to be my ZBrush displacement, so that's what I'm going to add in here. And the other one's going to be the tileable displacement. I've got my height map plugged in now, just naming it to, just adding a range node to each of these and renaming that to height range and then ZBrush range. So I can have control over the intensity of the displacements of these. So I think that this diffuse map was sourced from Texturing XYZ, so it comes with a bunch of different maps. But if you was to just search on Google and find the tileable alpha, then you could very well just use a single diffuse or even just a single alpha, and then use that to grade for different purposes. So, you know, use it in your diffuse, use it in your roughness, specularity. There's a lot you can do with a single map when it comes to things like cloth. So it's a lot simpler. So I'm just showing here that I have smoothed the cloth geometry inside of Maya. In the viewport it is smoothed, so I am going to bump it up to an extra iteration of subdivision in the cat clock option. But it doesn't need too many because it is smoothed anyway, so it should be enough to displace this level of detail. If I feel like it's not displacing it well enough, I can just up the cat clocks to say 2, 3, but again it will slow down render times. So I'm trying to be clever with how I'm doing this. And the lever is going to feel a lot more subtle. It doesn't need to bump out as much, so I don't think I need as much subdivision. So I'm going to jump back into my displacement again and just tile this map to 15.15 as well, just like the diffuse, so they all align with each other. So you can see the intensity is too high, so I'm just going to go into the range node and then maybe drop that down to a tenth of its default, so 0.1. And I've just put on the screen a image of a leather material just so we can have something to look at while I'm working and see how I'm using this reference to kind of, you know, influence my look dev. And yeah, so a value of 0.1 feels a lot better now. We're getting the detail, and this is simply just using a single diffuse and a single displacement or height map. So very, very simple right now, and we're already getting a nice sort of leatherish feeling. And I've just increased my exposure as well in my render just so I can actually see it. Otherwise it's pretty dark. So now I'm going to connect the specular roughness map. So same process as before. So it's very repetitive, all of this stuff. You know, it is just connecting file texture maps and connecting color correct nodes so we can actually, you know, drive the look we want inside of Arnold. So nothing complicated here. So just setting them up to raw and the repeat UVs to 1515. And then we can see what this map looks like. Obviously you can see in the render that it was feeling very rough, and you can see why, because the map's basically white. So I can play around with the contrast pivot and the contrast here in order to get some variation. The variation's what it's all about, you know. The more variation you can have, the more natural and realistic something's going to look and feel. So I'm just playing around with this contrast pivot value here, and trying to find something that gives me enough variation. So very simply just using the multiplier, sort of a global darkening of the roughness map, and then you can see now that we're getting some nice little hints of roughness variation, but also still feels shiny and doesn't feel rough anymore. And I'm just going to disconnect this and put it on its default value just to show you what the actual roughness map is doing compared to kind of a default roughness value. So we can of course potentially bring our roughness back down a little bit more so we have a little bit more shine to our level, but just the kind of look and feel of this is a lot more breakup in those cracks. It's aligning with the displacement and the color. It's all working together to kind of give us a very kind of cohesive feel. Feels a lot more natural. Very simply what I'm going to do now is connect my specular map. This way I can actually drive the intensity of the specularity as well. And a specularity map, you know, is also going to enhance this more. The darker areas of the specular map are going to feed into the cavities of the leather material. So it almost act like a cavity map. Just give us an extra boost of variation. Of course, you can see the specularity map here. Just changing that to 1515 as well. And we can use the color correct to kind of boost the exposure. So you can see the specular map's pretty dark, and it's darkened our highlights. So just using the exposure to boost this map back up again. You can see how much sort of variation detail is adding. I want to render the jacket as a whole now and get some context. You know, working in small regions for too long isn't the best idea because you lose a sense of the wider picture. So it's important to render the entire thing and take a step back. Something that I feel is that, you know, I have exposed the image up to 2 and I feel like the highlights still don't really pop enough and there's not enough contrast compared to the photography that I'm looking at. So I want to utilize the coat attribute and bring up the weight to around 0.5. And I think in order to get a little bit more of that variation, as I keep talking about, is to plug the color correct that I'm using for the specular roughness into the coat roughness also. And yeah, you can really see the pop of highlight now in the specular response. So now as I bring my exposure back down to 0, you can really see the difference that's made. I do feel like potentially still a little bit too rough, so I think I'm going to jump into my color correct for my roughness and just drop the multiply down just slightly more. I think a bit more of that contrast really reads as leather. So, yeah. And I'm going to render it as a whole and see what that feels like. And you can see the ZBrush displacement at work here. So I did do a lot of sculpting sort of on the edges of the material to kind of give it that hemmed feel. Just really adds that extra boost of realism when you've got, you know, a natural sort of fabric feel where you've got the sewing on the edges near the zip. Some inflation around the edges of the collar and just, you know, more creases and wrinkles in general. So I'm happy with that feel for the leather jacket now, and very simply just going to select my metal zip and buttons and assign a new standard surface. And I like to just do a very quick preset with this one, and this preset I would use is the brushed metal preset. And then just press play on my render and we can see how simple this is. And again, of course, you can go in and really add variation to these things. I didn't really feel like it was necessary here. I feel like it did the job pretty well, but absolutely go in and push these elements further if you wish. Presets are great just to save you time on very simple materials that you don't really need to spend a lot of time on, like zippers. You know, I didn't feel like I needed to go for anything with lots of grime, dirt or scratches because it was never going to be about the cloth with this project. So, you know, there is a sense of priority that's happening here, but absolutely for look dev purposes. If you want to do your research, go and have fun texturing sort of lots more variation in these smaller areas. So with the t-shirt, just assigning a standard surface again. And we're going to be basically doing the entire thing I've done with the leather jacket now on a t-shirt, which is very much just base color and displacement. It's a lot simpler than the jacket actually. So just doing what I did before here, which is the 2 file nodes connected to an AI range and connected into a plus minus average for the displacement. So that'll be our height again and our ZBrush displacement. Okay, then press and play on a render. I think that this displacement map was sourced from Flip Normals. So this is a cloth pack that they had. And yeah, lots and lots of interesting stitch patterns. So I think I used one of the sort of cotton stitching patterns that they had. And very simply just using that one map just for the displacement here, and just going to tile it. It's going to have to be tiled pretty high because you can see just how large that one stitch is on the t-shirt. So trying 100 first. And again, the t-shirt has been smoothed. Add on your cut clock subdivisions to it to make sure that you're displaying this sort of level of detail. You can see that it's displaying the detail relatively nicely here at 100, and so the subdivisions seem to be enough here. Don't overdrive it unnecessarily. So just work in increments and see if it makes a difference up to a point, because there'll be a point where you change your cut clocks from say 3 to 4 or 4 to 5 and it really is just not making any visible difference, but you're slowing down render times considerably, so just be aware of that. Okay, so happy with that for now, and I'm simply just gonna explain that with things like t-shirts, you do have a sort of the cuff of the sort of neck cuff of the t-shirt, which would be sewed onto the main t-shirt. So this is UV'd in a sense where I could actually assign the cuffed areas of the t-shirt separate material, and so it can have a different look to the displacement there. So you wanted the displacement to feel maybe stronger, or the repeat UVs to be lower there, you have that option. So that's an option to do there, and that's with good UVs on cloth, kind of UVs that are representative of how cloth would actually be sewn together, which is pretty important. So with the color, I've very simply just added a noise map to the color attribute, and I'm just going to drive everything here. So I just use red just to kind of demonstrate what you can do, where you can change the scale of the noise, the color, the distortion, lacunarity and amplitude, and so on. So yeah, I'm just changing the color just to kind of show you what's happening and what it can look like. So just mess around with the attributes, unisolate selected, and we need to, of course, alter our specularity and roughness values here, because it's obviously very shiny, which is not what sort of a t-shirt fabric feels like. So I'm going to increase the roughness pretty high. So again, it's all about just looking at photography and understanding also the light setup that you have, which is why I say about, making sure to surround your models with different light environments to make sure that you are capturing the right essence. It's easy to kind of look at one image of leather and think, oh, it's very shiny in this image, so I'm going to make my leather very shiny. But are the light sources the same from the photography to your scene? So it's those questions you have to ask, and it's why you have to collect a variety of different references. If you were lucky enough to maybe do your own shoot, and then you could then recreate that lighting inside of CG, then you could definitely say, all right, I need to match this one-to-one. And that's the fun of look dev, really. So just adding some sheen here, which is, a great feature in Arnold when it comes to fabric. It kind of just adds a sort of a layer on top, this kind of feeling of fuzz. And this is something to experiment with. I'm going to stick it on white for now, with a relatively low weight and a roughness of around 0.2. Just adds a little extra something to the cloth. Going to lower down the roughness slightly more. Feel like it's become a little bit too flat looking. So yeah, just lots of look dev tweaks, to the to the amount of repetitions to the tileable displacement, you know, the roughness. And now I've just kind of globally changed the color. Red was more just a demonstration. So now I can use the color correct node in the diffuse attribute and bring it to kind of a blue color, which is what I wanted originally with this project. And yeah, so you can see here the tileable displacement and the ZBrush displacement at work, and everything else was just driven by just simple values in the shader and a noise map for the diffuse. So very, very simple. Again, this is something that you can really experiment with and push your shaders with, you know, more complex setups. I've kept it relatively simple here. So lastly, what I want to show is the straps on the leather jacket, which is essentially the leather material, but I can't assign the leather material because obviously these are separate pieces of geometry with separate UVs. Okay, so they're not attached to the main geo. I can't attach the ZBrush displacement to these straps because that corresponds with the jacket displacement. So all I'm going to do is just duplicate the shader inside of the Hypershade, and this way I can assign the lever, everything's still there for me, and I just need to replace the ZBrush displacement with the strap displacement. And it's really as simple as that. And yeah, this is the great thing about duplicating inside of the Hypershade. You can simply duplicate the shading network and it duplicates all of your color correct nodes, all of your file nodes, and all of the paths to the file nodes. So the way that I do this is I can take the displacement setup that I created for my jacket. I can select the displacement node. I'm going to call that jacket disp so it doesn't get confused. I'm going to jump up to edit, duplicate, and shading network. And you can see here jacket disp 1 and the entire shading network duplicated. And I can call it, you know, buckle disp or strap disp, whatever you want to call it. I'm going to graph this, and I'm going to simply middle mouse drag it into the jacket material 1, which I should rename to strap material. So this is a duplicate of the jacket material into the displacement material. And then very simply, I can replace the ZBrush displacement with the strap. And there we have it. So literally in a matter of a minute, we have a duplicate of the shading network without having to recreate anything and just replacing one single file. And so you can see the strap displacement at work there. And I'll just do that to the other side because that's also a separate geo with separate UVs as well. You know, I could have really simplified things for myself and actually had them both in one UV set together, but I did export them separately at the time as different geometries. So yeah, super simple here. And there we have it. So that's the cloth. And the great thing about having these as separate geos as well is being able to say, if you wanted to change, you know, the colors of these straps, for example, you have them as separate pieces. So you have the option to. Or if you wanted the leather tileable repetitions to maybe be larger or smaller, you have that option too. Everything's duplicated, but nothing gets replaced. So this is completely independent of the strap now, what I've assigned to it. Yeah, so I'll simply just do the exact same thing now and just duplicate the displacement and the jacket material for the left-hand side, and that's it. So yeah, making sure to rename when you do stuff like this, because otherwise it can get a little bit confusing with what material corresponds to what geo. So yeah, that's it. That's the cloth. So now that I have all my shaders set up, and I feel like everything feels relatively good here. You know, there's always tweaks that you can do. Looking back at this project and actually reworking it again for the tutorial, there are some things that I approached a bit differently and taught a bit differently based on the experience that I've had since working on this. But there are still so many things that I would change, modeling wise, texturing wise, even grooming wise as well. So, you know, those are things I didn't change with this because, you know, it's an older project. I didn't feel the need to have to totally revamp or rework it. I felt like it was definitely a good enough project with a lot of different aspects to it that I could teach well and demonstrate my look dev with. I still approach most things the same now. Just that with a different eye, since I worked on this a year ago, I definitely feel like there's a lot of things that I would change and just update and better, basically. So for me, there's still kind of like that glowing feeling on those eyelids. Definitely would reduce those. I definitely create a new meniscus geometry, something more tubular, like I mentioned, to kind of, avoid having to use things like opacity maps. I still feel like the skin itself, just kind of that, the displacement map, feels very strong in certain areas, which could have been masked out with more maps, which, I could definitely just do. There's just loads of little things that I would definitely introduce or better now that I've looked at it a year on. But this is all part of the process with 3D portraiture, and anything that you do in life, it's always about progressing. And hopefully this tutorial is a great introduction in a way into kind of character look dev, photorealism, how to kind of approach shading in Arnold. But the thing that is difficult to teach is, how to study photography, how to actually observe real life. And that is something that you just become more and more equipped with as you practice and as you continue to do this sort of stuff over and over again. I've worked on loads of portraits now, and with each one I learn something and I take it on to the next portrait and the next portrait. And it's something that it's just about the time and the energy that you put into the work that you do and the love that you put into it. When you really care about the subject you're working on, or the portrait or the project, you'll put in the time. And so that's why I always tell people to work on something that interests them. I love doing faces, I love doing people, so that's why I do it. If I was to work on environment or some sort of architectural look dev work, I wouldn't be as interested. So I probably wouldn't put the time in, and I probably wouldn't study as much. So this sort of stuff just comes with a lot of practice and experimentation. These are just some concepts I've taught myself, and then eventually you could go on and use more nodes and begin to advance some of these setups and create something even more complex. And I'm sure that you guys will come up with even better techniques and methods than me eventually as well. I'm always trying to learn. So hopefully things that I've taught myself, I can teach you, and then you guys can go on and create even better methods and teach other people too. So yeah, this is one of the renders. I'm going to sort of do a little slideshow at the end of all of those cameras and the final sort of renders and comps. The comp is very simple, just wanted to get a bit more of that interview sort of color grading into and yeah, I hope you guys have learned something from this, and it's all about practice. If you feel like you're struggling with the look dev, maybe it's a problem with the model and the textures as well. They all come hand in hand with each other. So it's an iterative process and it takes time. So consolidating all of this stuff in some short videos is not representative of how this sort of stuff actually works. It takes a lot of time. It takes a lot of patience. Sometimes going away from a project for a week or a few days is a great way to freshen your eyes, come back, and maybe you'll notice some more problems. Even just things like I mentioned earlier about getting the groom in place is a great way to see your character come to life a bit more, and then it introduces more problems, and then you may want to go back and fix the sculpt, fix the textures, etc. So best of luck. I hope you've enjoyed the tutorial, and yeah, feel free to find me on social media and send me anything that you've created from it, because I'd love to see. Thank you very much for watching.